Okay, so this is lesson 6.2, your turn, some extra practice on your own, some try these questions, and we're just looking a little bit further at functions, at rate of change, and classifying functions. So you could do these on your own without the video, or you could just use this video as the answer key to check your solutions and fast forward as you need, or listen to the explanation as you need to. So the first thing that we're going to do is we're going to do this activity where it's investigating a constant rate of change. So reading the scenario, the U.S. Department of Agriculture defines heavy rain as rain that falls at a rate of 1.5 centimeters per hour. So we've got our rate of change here, 1.5 centimeters per hour. And in part A, the table shows the total amount of rain that falls in various amounts of time during heavy rain. Complete the table. So we're going to assume that rate is falling at a constant rate of 1.5 centimeters per hour. So we're going to go ahead and complete this table. So if at 1 hour it's 1.5, at 2 hours it would be 3, at 3 hours it would be 4.5, and I'm just multiplying 1.5 times my input, right? So this is my input, this is my output. 4 would be 6, and 5 would be 7.5. And this is in centimeters. This is the total amount that falls in rain. We're going to go ahead and plot the ordered pairs now, because these are our ordered pairs, on the table over here to the right. So my first ordered pair would be 0, 0. X is 0, Y is 0. And then 1 and 1.5. So there's 1, there's 1, there's 1.5, approximately. Then 2 and 3. Then 3 and 4.5, about there. 4 and 6. And 5 and 7.5. Okay? And am I going to connect these points? I actually am going to connect these points because this is, I can at any time I can figure out how much rain has fallen. So the space between the lines represents values of rain that falls during that time also. So it's okay to connect these points. So how much rain falls in 3.5 hours? Well, what I'm going to do is I can use my graph to figure that out, or I can plug it into an equation that I can build from this. I know that I can use y equals mx, and I'm not going to have a plus b because I see that it starts at 0. In this case, it would be y equals 1.5x, 1.5 centimeters per hour, and I want to find out what it's going to be at 3.5 hours. So I could just plug that in. You could also just check your graph. Now it's a little bit hard to see here, so if this is 3.5, it looks like it's slightly more than 5, right? So you can't really get an exact value. I could estimate approximately 5.25 inches, or I can use my equation to check. And if I plug these in, if I multiply these by each other, then I can see that my estimation is right and that this is 5.25 centimeters. So in 3 hours, we get 5.25 centimeters of rain. So I'm going to go ahead and plot that point, and I'm going to plot it in blue. And I'm going to see if it falls on my line, which I believe it does. And so what do you notice about all the points that you plotted? Well, they all fall along a straight line. And I already connected them, so I knew that. And now connecting concept, what does that mean? What does that tell me? That tells me that this is a linear equation. And if it's a linear equation, it's also a linear function. And if it's linear, then it can also possibly be proportional. Now, not all linear equations are proportional, but maybe they are. And in this case, this one is also proportional because it starts at 0, 0. So that's important to know as well, that this is a linear function and it's proportional. So just building off those concepts that we just did. So F is asking us, is the total amount of rain that falls a function of the number of hours that the rain has been falling? So is this relationship a function? Is time and the amount that falls, is it a function? Is the amount of rain that falls a function of time? Does it depend on time? Yes, it is a function. any given input, there can be only one output, right? And in this case, input is rain, or input is hours. Only. Which in this case, the output value is centimeters of rain. And that makes sense if you think about it in context, right? That's saying that, okay, well, you can't have two different amounts of rain in the same location at the same time. It wouldn't make any sense for there to be, at 2 hours, 3 centimeters of rain and 6 centimeters of rain in the same place at the same time. Not possible. So this is a function. So let's go ahead and reflect. Suppose you continue to plot the points for time between those tables, such as 1.2 hours and 4.5 hours. What can you say about the locations of these points? Well, we already did that, right? We already determined that these points all lie along a straight line, and at any point, any input value along here, there would be a corresponding output value. So you can predict them. You could predict what the output is going to be. So they would fill in the gaps along that line. So what can you say about them? Well, we could say a couple different things, but we're going to go ahead and say that the points would fill in the gaps, right? Along the line. All right, and that would just continue to illustrate that this is a function of time, that rain is a function of time. So this is a good actually review exercise because it reviews rate of change, it reviews do you connect points on a graph, it reviews plotting points, and it reviews what is and is not a function. In addition to, is it a linear function or is it a nonlinear function? So that's a good little review activity there. Hopefully it clears up some confusion for those of you guys who might still be struggling a little bit. Let's go ahead and move down to these two here. We've got your turn number 2, where it wants us to state whether the relationship between x and y equals 0.5x or 1/2 x is proportional or non-proportional, and then graph the function. So we know it's a function. We want to determine if it's proportional or not. Okay? So when I look at this, I've got y equals 0.5x, and I know that it should make an equation of y equals mx or y equals mx plus b. In this case, it does match this equation, y equals mx. It does have a constant rate of change. It does have an input and an output value, so this does represent a linear equation. It doesn't have a b value, so what that tells us is since there is no y-intercept, is that it is proportional, that it's going to start at 0, 0. So just looking at that equation, we can tell that it is linear and it is proportional. Okay, so we can go ahead and write that down. And remember that if it's not linear, it cannot be proportional. It has to be linear to be proportional. And then we can go ahead and graph these. So what we're going to do is we're just going to plug some values into that equation. So let's go ahead and plug in x of 1, x of 2, and x of -3. So we'll plug those in and see what our y values are. Let's get 3 points and see what that looks like. So I get 0.5 times 1 is going to be 0.5. I've got y equals 0.5 times 2, which is going to be 1, because it's 1/2, right? And y equals 0.5 of -3, which is going to be -1.5. So I'm going to go ahead and just plot those points just because it wants us to. You can fast forward to this if you think you've got the idea. X is 1, y is 6, 8, 10. So these are by 2. This would be 1. So 1.5 is going to be, oh, and this is 2 here. 2, 4, 6, 8, 10. Okay, so this would be 1. And 0.5, that's going to be like right there. I should have picked different values. 2 would be 1. And -3 to 3 would be negative 1.5. That's going to be right about there. So I should have picked better points, but I didn't. That's okay. So in the future, learning, teachable moment here, pick values that are represented on the graph easier. I should have picked like a value of 6 for x and a value of 10 or a value of negative 10, things that would have been easier to plot. But we did it anyways, and it's okay. Okay, last one we're looking at here is your turn, number 3. And it wants us to take a look at a soda machine. And that soda machine makes 2/3 gallons of soda every minute. That's a lot. So 2/3 gallons of soda every minute is our rate of change. The total amount that the machine makes in x minutes is given by the equation. Oh, look, there it gives this to us. Y equals 2/3 x. Determine if the relationship between x and y is linear. And if so, is it proportional? So I can go ahead and just look at my equation, right? So I've got y equals 2/3 x. And I want to compare that to y equals mx, or y equals mx plus b, right? Because this is linear, and this is linear and proportional. And in this case, once again, I've got no b value, but I do have a slope. Okay, so I've got no y-intercept, but I do have a slope. So that's telling us that this is linear and proportional. It means it's going to start at 0 at the origin, and then it's going to travel up in a straight line because it has a constant rate of change. So we're going to go ahead and fill in the table here, and we're going to look at this. This looks like it's increasing by 3 every time, so I'm going to guess this is 6. And then we're going to go ahead and plug this into our equation. Y equals 2/3 times 0. Well, anything times 0 is 0, right? So that proves to us that when x is 0, y is also 0. So that proves to us that it is proportional. We've got my next one here. Y equals 2/3 times 3. Remember, guys, review of multiplying fractions. 2/3. And I'm multiplying by a whole number. I can put that whole number over 1. And then I would just multiply straight across. So a lot of you guys immediately just try to convert this into a decimal, but a decimal actually will not give you as accurate of a solution as this fraction will, because it's a repeating decimal. So 2 times 3 is 6. 3 times 1 is 3. And this simplifies to 6 divided by 3 is 2. Okay, so this would be 2. Do you guys, bell? So then I'm going to plug in this next value here where x is 9. And I do just want to note that this does make sense for our pattern here. We have plus 2, plus 2. We can guess that this is probably plus 2. We can guess it's probably going to be 6. Let's just plug it in to find out. 2/3 of 9, right? So y equals 2 over 3 times 9 over 1. And a lot of you guys know how to cross cancel. I didn't do it in this previous one, but I'm going to do it here. So these have a common factor of 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So I simplified before multiplying in this case. So I've got 2 times 3 is 6, and 1 times 1 is 1. So this is 6, which does match what we've got in that table. So the equation shows us it's linear and proportional. The table shows us it's linear and proportional, and I bet the graph is also going to show us that it's linear and proportional. So my first point here is 0, 0, and I'm just pulling those points from the table. Then I've got x is 3, y is 2 from the table, and then the next one would be x is 6, y is 4. And then finally I've got x is 9, and y is 6. So what I see here is I do see a linear equation. I'm going to go ahead and connect those points because it is at any point we can determine how a value, corresponding value of the amount of soda made. And then I do just want to point out, guys, for this table, and this is all just kind of bonus information, just review bonus information, is that this table reflects my rate of change. My rate of change here is 2/3, right? So change in y is 2, change in x is 3. If I just apply that to my table, because on slope, y is on top, x is on bottom, and in tables, x is on top, y is on bottom. So if I apply that to my table, I should see that same thing here. I should see a plus 3, which I do, and a plus 2. So I could have used my slope there to fill in the table as well. Okay, so that's a long enough video, long enough explanation. Hopefully you watched it at a speed that was appropriate. Maybe you were able to fast forward and get what you needed. But if you needed some extra time and some extra examples, hopefully that helped. Of course, if you have questions, please bring them to class. Let's talk about them and go over any places you might need help. All right, guys, I'll see you in class, and we'll be working on 6.2.